Now we come to the session 31. Now we are come to the next unit 3 chapter numerical analysis. The numerical analysis, the finite difference. So we are defined what is a finite difference, basic definitions, some definitions, some examples regarding that. See, we are familiar about suppose if we take consider the equation form y is equal to f of x. Here y equal to f of x, we take a function 3x square plus 1 whatever may be. Here x is the independent variable, y is the dependent variable. We give a value for x, for all x. We give a value for x, y you get the values of y. So x is the independent variable, y is the dependent variable. Suppose put x equal to 1, y suddenly we get y value. So you are giving the values of x is independently. We giving the value, we get the values of y. We get the values of y. Now the same way we are expressing what is the finite difference. So the finite differences is the calculus of the finite differences deals with the changes that take place in the value of the functions. So we are given, suppose if we give a values of x, we get the values of y. So x is the independent variable, y is the dependent variable. So it's in the same way, the values of the function dependent variable due to finite changes in the independent variable. Through this, we also study the relations that exist between the values assumed by the function. Whenever the independent variable changes by finite jumps, whether the equal or unequal. On the other hand, in finitesimal is the infinitesimal calculuses. So we study those changes of the function which occur when the independent variable changes continuously. So it gives the intervals. It gives the intervals. In this chapter, we shall study the variation in the functions when the independent variable changes by the equal interval. So this is our introductions about the finite differences. See, if it changes, one changes automatically changes the other. Means if it changes the values of x, automatically values of changes y. If we give a small increment, very instantly changes. Y also changes very instantly. So this is the way. This is called a finite differences. We come to the values. Suppose let y equal to f of x be given functions of x. Suppose if it changes, so why not we get a values. Suppose y equal to f of x be a given function of x. Let y0, y1, etc. yn be the values of y corresponding to x0, x1, etc. xn. So if it changes, x's changes. So x means x0, x1, x2, etc. etc. So corresponding changes y1, y0, y1, etc. So yeah, this if it changes one variable, automatically changes the other variable. So x is the independent variable, y is the dependent variable. If it changes the values of independent variable, so the independent changes depend on the y. So that is the term we saw. With the values of y corresponding to values of x. The values of y corresponding to values of x. That is we say y0, y1, etc. yn be values of y corresponding to x0, x1, etc. x. The values of x, the independent variable x is called argument. The independent variable x is called the argument, and the corresponding dependent variable y is called the entry. So x is called argument, y is called entry. In generally, the difference between the two consecutive values of x need not be same or equal. The difference between x need not be same or equal. So if we take a table, we write a argument and the entries as below. So if we take x and y, so if we take x and y, so we will take, if it changes x changes to x0, x1, x2, xs. The corresponding changes y0, y1, y2, etc. xn minus 1, we get yn minus 1, xn, yn. Yeah, if if we subtract from there, so if we first consecutive difference, suppose if we take a subtract, we subtract from each values of y except y naught. First keep initial value as it is. So keep the corresponding values of y, that is we take, if a difference, so y1 minus y naught, y2 minus y1, y3 minus y2, etc., etc., yn minus yn minus 1. The this result are called finite difference of y. So if you take a difference, constitutive difference, y1 minus y naught, y2 minus y1, y3 minus y2, etc., etc., yn minus yn minus yn minus 1. This result is called finite difference of y. They are denoted by delta y. So forward delta, we see the capital delta y. So this is delta y. So delta, suppose if we take here delta y naught, so delta y naught should be equal to y1 minus y naught. So delta y1 should be equal to y2 minus y1. So delta y2 should be equal to y3. So y3 minus y2, etc., etc. Generally, delta yn minus 1 is delta yn minus 1 is yn minus yn minus 1. So generally we take delta yn should be equal to yn plus 1 minus yn. See, you are observing. So delta y naught should be y1 minus y naught. Delta y1 should be y2 minus y1. Delta y2 is y3 minus y2. Delta yn minus 1 is yn minus yn minus 1. Delta yn is yn plus 1 minus yn. This is simple formula. See here, the simple delta denote the operations called forward difference operator. So this is the forward difference operator delta. If we come to the extend the same, if we extend that order, so it will be first order, second order, simply say higher order differences. So first, suppose if you take a second and a higher difference are defined. Suppose if you take a del square y naught. What's a del square? Simply we can write del square, we can del of y naught. Del of y naught. Simply, you know definition of y naught. So delta y naught. y1 minus y naught. Apply again, open that. Delta y1 minus delta y naught. Again delta y1 is y2 minus y1. What minus delta y naught means y1 minus y naught. So open this y2 minus 2 times of y1 minus of minus plus y naught. So generally we get y2 minus 2y1 plus y naught. We come to the again del square y1. So again del square we can write del of del y1. So del of del y1, del of y1 is y2 minus y1. Again del y2 minus del y1. So del y2 is y3 minus y2. Del y1 is y2 minus y1. Again as simplifying. So again we simplify. So we get, see if we observe, del y2 minus del y1 is y3 minus y2. Again minus y2 minus y1. So again open this y3 minus 2y times plus y1. So we get y3 minus 2 times of y1 plus y3 minus 2 times of y2 plus y1 we get. So you are remove that. So again we come to the del q y naught. Again apply del q y naught, we can write del square of del y naught. Again simplify, we get del square y1 minus del square y naught. Again we get simplifying y3 minus 3y2 plus 3y1 minus y naught. y3 minus 3y2 plus 3y1 minus y naught. We observe that the coefficients occur on the right hand side. So observe that the coefficients occur in the right hand side are simply the binomial coefficients in 1 minus x whole power n. So here observe the coefficients. The coefficients of higher degree, so del cube is y3 started, del square is y2 started. So del square we like that. The coefficient 2, 3 like that. Generally we can write, observe that the coefficients occur in the right hand side are simply the binomial coefficients in 1 minus x power n. Hence, generally we can write del power n y naught is yn minus nc1 yn minus 1 plus nc2 yn minus 2 plus etc. Generally the coefficients, see positive, negative, simply we can write minus 1 to the power of n y naught. So yn yn minus nc1 yn minus 1 plus nc2 yn minus 2 plus etc. plus minus 1 to the power of n y naught. Also, if we take nth del power n yi, simply we can write del power n minus 1 yi plus 1 minus del power n minus 1 yi. So, throughout this argument, x0, x1, x2, etc. did not a general be equal or generally equally spaced for purpose of practical work. We take them equal as spaced, usually the argument taken as x0. So first y0 we take first argument x0, y1 we take x0 plus h, y2 we take x0 plus 2h, y3 we take x0 plus 3h, like that. So this is the argument taken as x0, x0 plus h, x0 plus 2h, x0 plus 3h, etc. So that the difference is x1 minus x0, x2 minus x1, x3 minus x2, etc. This should be h, the equal difference. Simply say the equal difference. Differences are equal. Simply say the differences are, the consecutive differences are equal. I denote that letter should be h. H is called interval of the differencing. So the first forward difference of y equal to f of x defined del f of x equal to f of x plus h minus f of x. So simply say del f of x is f of x plus h minus f of x. So forward difference, the forward difference of the function f of x is f of x plus h minus f of x. Now we come to the next for some second forward difference. If you call the del in net, suppose what about in case of del square f of x, right? The second forward difference of y equal to f of x defined as, see, del square f of x. So del square f of x we can write del of f of x. Del of f of x is del of, if you apply del f of x is f of x plus h minus f of x. So again if you apply del of f of x plus h minus del f of x, so again apply this del of f of x is del f of x plus h minus f of x. Again you open that del f of x plus h minus del f of x. Again you apply the first terms, should be applying the del should be first term f of x plus h minus f of x plus h, f of x plus 2h minus f of x plus h. We apply the del for f of x plus h. So second term minus first term, like that. So second term should be f of x plus 2h minus f of x plus h minus del f of x be f of x plus h minus f of x. So open this term should be equal to f of x plus 2h 2 times of f of x plus 2h plus f of x. Generally we get f of x plus 2h minus 2 times of f of x plus h plus f of x. Generally we go for second order, third order, fourth order, etc. Generally we come to the nth forward difference is defined as del power n f of x is del n minus 1 f of x plus h minus del n minus 1 f of x. So this is the general formula for nth differences. So in these differences are systematically set out as follow in the form of a forward difference table. Forward difference table. What's there? Suppose the first, if we take argument entries, first difference, second difference, third difference, fourth difference, fifth difference, etc., etc. So if we take argument x, so x should be equal to x0, x1, x2, x3, etc., etc. Suppose x0 is initial value, so we keep as it is. So x1 can be written as x0 plus h, x2 can be written as x0 plus 2h, x3 can be written as x0 plus 3h, x4 can be written as x0 plus 4h. Similarly, entry depends on the argument. Y0 is x0. So simply y1 is x0 plus h, y2 is x0 plus 2h form. So suddenly y3 is x0 plus 3h, like that. So entry and argument. So entry depend on the argument we can rate. So if we take a differences, first difference we take y1 minus y0. So simply I denote that should be delta y0. So simply write. So in case of that we can write. So in case of if we write like this also in argument form also. So if we write, so if we come to the entries, the differences simply denoted by delta y naught. So if you take a difference y2 minus y1, say delta y1. If you take a difference y3 minus y2, say delta y2. Take a difference y4 minus y3, delta y3. So if it this is the first difference. If you take a second difference, so again del square, we get y2 minus y1, simply write delta square y naught. So if you take delta y2 minus delta y1, so it's del square y1. Again, if you take delta y3 minus delta y1, so it's a del square y2. So again we get a this pair. The third difference is the del cube. Again we take a difference del square y1 minus del square y naught, simply del cube y naught. Again del square y2 minus del y1, we can write del cube y1. Again take a difference that is called a fourth order differences. So suddenly we get del cube minus del cube y1 minus del cube y naught. Generally we get del raised to 4 y naught. So this is the fourth difference, fifth difference, etc., etc. Depend on argument and entries. Suppose we are taking the argument should be only a fourth term argument, so we are get fourth differences. Suppose if we take argument, entries should be a fourth or fifth, sixth term, so we get sixth differences. So that is the way. In this table, y naught is known as the first entries called leading terms. And delta y naught, del square y naught, del cube y naught, del rest y naught, etc. are called, see, this is the term. Delta y naught, delta square y naught, del cube y naught, del rest 4 y naught, etc. This is called leading differences. See, the first, this is called a leading difference. Simply say, this is a diagonal form. Simply say, this is the first differences called leading differences. Now, so similarly, we come to the, with this are all forward differences. Now we come to the backward differences. The backward difference operator simply denoted like this form. So in the reverse triangle form. So forward difference is upper triangular form. The backward difference reverse triangle form. Reverse triangle delta form. See, consider the function. The considered function y equal to f of x. Suppose we are given the tables of values of the function at the point x0, x1, x2, etc. So x0 we already initial argument. So simply say leading. X1 should be x0 plus h. In terms of h we can. X2 is x0 plus 2h. X3 is x0 plus 3h, etc. Xn is x0 plus nh. So that is we say f of x0 should be y0. F of x1 is y1. F of xn is yn. This is the function we can take. So argument depend on entries. So entry f of x0 should be y0. F of x1 is y1. F of xn is yn. That is the reverse delta. We write reverse triangle delta. You can write delta f of x equal to f of x minus f of x minus h. This is the definition. So delta f of x is f of x minus f of x minus h. So delta y1 is y1 minus y0. Delta y2 is y2 minus y1. Delta yn is yn minus yn minus 1. That is, this is it's called backward difference operator. So and delta y1, delta y2, etc. delta yn is called first order backward difference of the function y is equal to f of x. See, delta y1, delta y2, delta y2, etc. This is called first order difference operator of the function y equal to f of x. Now, if we come to this again, if we extend this order, so second order, third order, fourth order in backward differences, the second order difference of the functions del square y2 is del y2 minus del y1. Again apply for del square y3 is del y3 minus del y2. Del square yn is del yn minus del yn minus 1. In the similar manner, higher order difference can be defined. In generally, nth order differences say del n yi is del n minus 1 yi minus del n minus 1 yi minus 1. So this is the formula for backward higher order differences. So these differences of the function y equal to f of x can be systematically represented in the form of the backward difference table. Say backward difference tables. So you write x naught is initial, x naught, x1, x2, x3, etc. X naught is initial. If we write x1 can write x naught plus h, x2 can be written as x naught plus 2h. So x3 can be written as x naught plus 3h. X4 we can write x naught plus 4h, etc. So the entries should be y naught, y1, y2, y3, y3, y4, etc. Take a first differences delta y1. So y1 minus y naught, simply say delta y1. So y2 minus y1 we can write delta y2. y3 minus y2 we can write delta y3. y4 minus y3 we can delta y4. So similarly second operator, del second order we can write del square. So delta y2 minus delta y1 we can del square y2. So delta y3 minus delta y2 we can write del square y3. So delta y4 minus delta y3 we can write del square y4. Again, if we take a third order is del square y3 minus del square y2 we can write del cube y3. Again, del square y4 minus del square y3 we can del cube y4. Again, take this difference del cube y4 minus del cube y3 we can write del raised to 4 y4, etc. So this is the forward and backward difference operator. So we come to the fundamental theorem of finite differences. So the theorem says the nth difference of the polynomial of the nth degree, the nth difference of the polynomial of nth degree are constant, and all higher order difference are 0. Observe that the highest power should be a constant, all higher order should be 0. That is, we can write del power r of f of x is a constant when if r is equal to n, 0 if r greater than n. So if is constant if r equal to n, 0 if r greater than n. So if we take this function, if we take f of x will be a naught x power n. If we write a polynomial, we write a polynomial of degree n, write a polynomial of a degree n, a naught x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus etc. a n minus 1 x plus n, where highest power degree but n, that coefficient should not be a 0. We write where highest coefficient degree. So we write a naught should not be a 0. It be polynomial of a degree n, where a naught is called leading coefficients of f of x. So if we apply the difference, del f of x is the definition of del f of x is f of x plus h minus f of x. So again we apply this, replace the polynomial f of x is f of x plus h. That is, we get a naught x plus h whole power n plus a1 x power h whole power n minus 1 plus a2 x power h x plus h whole power n minus 2 etc etc. a n minus 1 f of a n minus 1 x plus h plus a n minus, if we apply the f of x in the polynomial form, minus a naught x htn plus a1 x htn minus 1 plus a2 x htn minus 2 plus etc. a n minus 1 x plus a n. So again we get a difference. So we expand that. We take a coefficients of a naught, a1, a3, a4, etc. a n minus 1. So we take a coefficients outside, a naught of x plus h whole power n minus xn plus a1 x power x plus h whole power n minus 1 minus x power n minus 1 plus etc. a n minus 1 of x plus h minus x. That is, we can write a naught. If you expand this, the binomial expansion form, x plus h whole power n, x plus h whole power n, we get x power n plus nc1 x power n minus 1 h plus nc2 x power h n minus 2 h square plus etc. h power n minus x power n plus similarly a1 times of, expand again, if you binomial of degree n minus 1, we get x power n minus 1 plus n minus 1 c1 x power n minus 2 h plus etc. h to the power of n minus 1 minus x power n minus 1 etc. Again coefficients of a2 form, a3 form etc. a n minus 1 coefficients x get cancelled, we simply get h. Again we simplify inside, so x power n plus x power n minus x power n get cancelled, simply say a naught. So again this is the form of that higher power, simply write a naught of a n a naught nh x power n minus 1 plus, again I am taking coefficients of this a0 h square nc2 plus a1 h n minus 1. So you are simplifying nc1 nc2 like that. We get n minus 1 x power n minus 2 plus etc. an h. So if we expand here, sum, again I take in the first term coefficients of a0, second term coefficients of a0, third term coefficients of a1. Simply we can write a0 n h x power n minus 1 plus a0 h square nc2 plus a1 h n minus 1 x to the power of n minus 2 plus etc. Lastly we get a n minus 1 h. Again we are simplifying. So a0 n h x power n minus 1 plus a0 h square nc2 plus a1 h x power n etc. This is the, again I open this terms. So this constant denoted by b2 b3 etc. So again this a0 n h x power n minus 1 plus, again this is the, I take coefficients of x power n minus 2, this terms denoted by b2. Again x to the power of n minus 3, the coefficient of x to the power of n minus 3 I denoted by constant b3. Again the coefficients of x raised to n minus 4 denoted b4 etc etc. So we get bn minus 1 x plus bn etc. So where b2 b3 etc are constant. Again we come to the, from call that term is clear. So clearly this is the first difference of f of x in the polynomial of n minus 1 third degree. So in the start. So similarly del square f of x we get del of f of x is del of f of x plus del of f of x. You apply del f of x is f of x plus h minus f of x. Again apply the del, we get del f of x plus h minus del f of x. So again we are expanding here in the same form. We get it a0 nh x plus h whole power n minus 1 minus x power n minus 1 plus b2 x plus h whole power n minus 2 minus x power n minus 2 plus etc. bn minus 1 x plus h minus x. So simplifying. So again we take expand a0 n minus 1 h square x to the power of n minus 2 plus c3 x power n minus 3 c4. So this coefficients, again we get some coefficients b2 term again x term. So product b2 x power something, b3 x power something, again that product is a constant. I take outside for x power n minus 1 the coefficients of x power n minus 1, x power n minus 3, x power n minus 4 etc. The coefficient of x power n minus 2, x power n minus 3, x power n minus 4 should be denoted by c3, c4 etc. So that is c3, c4 etc. These are our constant. So this is the difference of second difference of f of x reduced to polynomial of n minus 1, n minus 2 degree. Similarly, the same process we expand. The process is continuing. The proceeding as the above and difference for n times we get del power n f of x is a0 n minus 1 etc etc 3 a0 n minus 1 n minus 2 n minus 3 etc etc 3 into 2 into 1 h power n x power n minus n nth degree. So simply write x power n minus n minus n. So simply say a0. What's n minus 1? n minus 1, n minus 2, etc. 3 to 1. Generally we can write n factorial. H to the power of n. X power n minus n. So x power 0 we get 1. So simply we get a0 n factorial h power n. It's a constant. This is all a constant. Again, this is the, simply we can write this form delta to the power of n plus 1 f of x. So delta power n f of x. You are simply calculated delta to the power of n f of x is a0 n factorial h power n. Apply delta of a0 n factorial h power n. So if a difference is 0, this is constant. Again differences should be 0 because constant derivative constant is 0, which is the complete proof of the theorem. Now we observe here the difference of the above theorem is true. Means we observe here, see this. So if the constant we are again differences we totally is 0, which is the complete. Now the note, the converse of the above theorem is also true. If the nth difference of the function tabulated or at equally spaced interval are constant. The function is polynomial of degree n. So function is a polynomial of degree n. This is the form, the finite difference form. If in a degree constant, that is degree n, the higher power of degree is 0. If you take a simple difference, if a simple problems, evaluate del power 10 in a 10th degree, 10th degree of 1 minus ax, 1 minus bx square, 1 minus cx cube, of 1 minus dx raised to 4. Means del power 10 of 1 minus ax of 1 minus bx square of 1 minus cx cube of 1 minus dx raised to 4. So that is del power 10 of 1 minus ax of 1 minus bx square, 1 minus cx cube, 1 minus dx raised to 4. That is take. So if we expand in the inside, suddenly a minus b minus c minus d. So minus, so we get positive. Suddenly we get a product a b c d. We write a b c d. So what's highest degree power? X power 4 here, x power cube here, x cube x. So total difference. So totally we get x power 10. Plus again this is the highest power coefficient. The highest degree coefficient is 10. Again coefficient of x raised to 9 plus coefficients of x raised to 8, coefficients of x, like that, the constant. Suddenly we get a b c d del power 10 of this. Again this is set. So simply say the formula we can write. So h power n minus, so degree 10. So suddenly is n factorial. So x power 10 minus 10 is 0. Is x power 0 is 1. Simply say a b c d, whatever this product. Instead of a b c we can write, you give a number, put a is number, b is some number, c. Right. A b c delta to the power of 10, x power 10. Suddenly this is a formula. A power n, h to the power of n factorial. Simply a naught, h to the power of n factorial. This is lastly we get now. So a naught n factorial h power n. So similar same formula we can apply here. ABC is constant, generally is n factorial. What's n factorial is 10 factorial. So we 10 factorial we can write 10 into 9 into 8 into 7, like that. That product we get. Similarly we come to the simple example. We come evaluate del cube of 1 minus x, 1 minus 2x, 1 minus 3x. So the same formula we can, let we call this function to be f of x. Let f of x equal to 1 minus x, 1 minus 2x, 1 minus 3x. Expand inside here. We get expand, highest power is x cube. Suddenly x cube. The constant a b c d, a b c. A is 1, b is 2, c is 3. So a b c is 1 into 2 into 3. So suddenly 6. So minus into minus plus, plus into minus minus, minus 6x cube. Again we get a product, coefficients of x square is 11x square. Minus coefficients of x minus 6 plus constant term. Because suddenly this is a polynomial of degree 3. Suddenly we can write minus 6x cube plus 11x square minus 6x plus 1. So again this f of x is a polynomial of degree 3 and the coefficients of x3 is simply write minus 6. The coefficients of x cube is minus 6. So here an is minus 6. Coefficient an is, h is 1. The constant difference is 1. So degree is n is 3. So del cube f of x is a naught in factorial. So n is 3. So simply we get n a constant is minus 6. 3 factorial. N factorial is 3. So minus 6 into 3 factorial. 3 factorial is 6. Minus 6 into 6. So 36. This is the value we get.